In this example, we are going to use DeepTrack 2.0 to track multiple particles in 2D. Hello, I'm Saga and I will be your guide to this tutorial. Let's go through example 4, where we use DeepTrack for multiple particle tracking. First, we import the objects needed for this example, and we load the experimental videos we will analyze later with DeepTrack. Here, we also specify the size of the images the network will be trained for. Then, we define the dataset. The training set consists of simulated images. The particles are simulated as point particles, and the particle position is set somewhere within the image, and given a vertical position. These values are based on pixel units, and the particle is also given an intensity. And the number of particles is set randomly between 10 and 20 per image. Now that we have defined the particle, we will image it. The particle is imaged using a fluorescence microscope, with numerical aperture between 0.6 and 0.8, and illuminating laser wavelength of 500 nanometers. And we also define the resolution and magnification of the microscope. The noise of the images is simulated as Poisson noise with signal-to-noise ratio between 3 and 4. And finally, the images are normalized. We then define the training label as a mask of the images, where each particle is represented by a white disk with a radius of 3 pixels on a black background. And now it's time to visualize the training images. Now that we have our training dataset ready, we move on to the network. Here we use a small UNet. The network is compiled with a binary cross-entropy loss, and the network is trained in 2 sessions. In the first session, the loss is weighted such that the setting a pixel value of 1 to 0 is penalized 10 times more than setting a value of 0 to 1. This helps the network avoid the very simple local optimum of setting every pixel to 0. In the second training section, the 2 types of errors are penalized equally. Here we see the model summary. And now for the training of the network. We use the continuous generator to continuously generate images during the training. If we keep train model as false, we load a pre-trained network that we have available for this problem. Or if we want to train a new model, we change train model to true. Here we have a validation set of 256 images, and a minimum of 2,000 training images, and a maximum of 10,000. And we use batch size of 32. And for the first training session, we train for 10 epochs, and 100 epochs for the second session. And now let's train the model. After the training is completed, we can visualize the training and validation loss. And now we evaluate our trained network. First, we test the network on simulated images that are generated in the same way as the training images, but they are not the same images as used in the training. And here we show a prediction of each output versus the ground truth value. And finally, we test the model on some experimental data. We track a video of quantum dots, where the white circles show the position predicted by DeepTrack.